Hello, welcome back to my YouTube channel. So today we are going to discuss about limiting case of binomial distribution to normal distribution. So we all know that binomial distribution limits are from 0 to n. N in the sense what? That is finite variables. But if n is not finite, that means infinite. What will happen? Nothing but this distribution will turns to normal distribution. Okay, so that we are going to prove now. So statement, first we have to write statement. Binomial distribution turns to normal distribution as n turns to infinity. Okay, as n turns to infinity. Okay, so now we are going to prove this one. Proof. So we all know that binomial distribution having n comma p parameters. So for binomial distribution, n comma p are the parameters. In the similar way, mean of binomial distribution, mean equals to np, variance equals to npq. Okay, so now movement generating function, that means mx of t equals to q plus p into e power t whole power n. This is binomial distribution information. And also one more formula, that is the standard binomial variable is given by z equals to x minus expectation of x by square root of variance of x. V of x is nothing but variance, E of x is nothing but mean. Okay, so this is standard binomial variable. Okay, so this is known as what? This is a formula for standard binomial variable. So here we are going to write mean and variance. That means x minus np by square root of npq. Okay, so x minus np by square root of npq. Okay, so now what we have to do is the moment generating function of z is given by, that means here mx of t is going to change as mz of t. Why we have to change? Because here binomial distribution is turns to normal distribution, we told. So in normal distribution we are having z variable. So that's why mx of t is going to change as mx of t is going to change as mz of t. Okay, so that's why we are going to write mz of t equals to expectation of e power tz. Okay, not tx, tz. Why? Because here z is there, no? So that equals to expectation of e power t into z, in the sense what? X minus np by square root of npq. So this z value we have to keep here. So z equals to x minus np by square root of npq. Okay, so now what we have to do is we have to multiply this t with this term and this term. Okay, so expectation of e power tx by square root of npq minus npt by square root of npq. Okay, so now if you observe, this is in the form of e power x minus y. So e power x minus y means what? We can write e power x into e power minus y, we can write now. So in the similar way we are going to split this one. Okay, so mz z of t equals to expectation of e power tx by square root of npq into e power minus npt by square root of npq. Okay, so now what we have to do is here this term. Okay, this term, how it is? Here we are not having any x terms. Here we are having x. That means variables we are having in this term. But in this term we are not having any variables. So we are taking this as constant. So e power minus npt by square root of npq into expectation of e power tx by square root of npq. So we all know that expectation of e power tx means what? What is this one? This is nothing but mx of t, isn't it? So that means here we can write what? Mx of t we can write now here. So that's why here I am going to write e power minus npt by square root of npq into m x of t. T in the sense what? T by square root of npq. Okay. So now what is the formula for mx of t? Mx of t formula is q plus p into e power t whole power n. So this formula we are going to use here. Okay. So that means e power minus npt by square root of npq into q plus p into e power t. T in the sense what? This term. T by square root of npq whole power n. Okay. And if you see, here we are having n. This is whole power n. If we bring this term inside, we can also write here whole power. So that's why this term I am going to bring inside. So that means, see here, q into e power minus pt by square root of npq plus p into e power minus pt by square root of npq into e power t by square root of npq whole power n. Okay, why? Because this term I multiple with both the terms, and by removing this n I have written whole power. Okay, so hope you understood this. That equals to here q into e power minus pt by square root of npq plus p into e power. See, if you observe here, in these both terms we are having bases are equals, power should be and no. So I am going to take here t as common. So t common తీసాము అంటే t by root npq I am going to take as common. So here what we will have? 1 minus p. Okay. So 1 minus p we are going to have. So 1 minus p is nothing but what is 1 minus p? Q. So that means q into e power minus pt by square root of npq plus p into e power tq. 1 minus p is nothing but q by square root of npq whole power n. Okay. So now it is in the form of e power minus x. E power minus x formula is nothing but what is the e power x formula? E power x 1 minus x by 1 factorial plus x square by 2 factorial minus x cube by 3 factorial plus and so on. This is e power minus x formula. Then what about e power x formula? So e power x equals to, e power x formula is nothing but 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus and so on. If it is plus sign, everything will be in plus sign. If it is minus sign in the power, alternate signs we get. Okay. So now we are going to write here in this way and here in this way. Okay. So this is mz of t equals to, mz of t equals to, first q we are having. So q into e power minus x means this one. 1 minus x, x in the sense what? pt by square root of npq by what? 1 factorial. 1 factorial is nothing but 1 plus, plus sign we are having here. Again x square. X square in the sense what? pt whole square. That means p square t square by 2 factorial into square root of npq. Okay. Again minus cube. X cube in the sense what? p cube t cube by 3 factorial into square root of npq into whole cube plus and so on. Okay, this is completed. Plus again what we are having? Plus p into this formula 1 plus x. X in the sense what here? t cube by square root of npq. So t cube, that means qt or tq, anything. qt by square root of npq by 1 factorial means nothing but 1 plus x square, that means q square t square by 2 factorial into square root of npq whole square plus q cube t cube by 3 factorial into square root of npq whole cube plus and so on. Okay, here whole power n, or else we'll write whole power n. Okay, so now what we have to do is, now we have to take common here. Q into 1 is q, p into 1 is p. Okay, so first we are writing only the terms which is not having any t terms, only these two are having. So that's why first we are going to write q plus p plus, so on taking common here q p we are having, here p q we are having, t if we take common. So like that again t square terms, again t cube terms. After simplification, if we take common, we'll get the final answer is t square by 2 factorial into n plus t cube by 3 factorial into npq whole power 3 by 2 into pq into q square minus p square plus and so on. So you all know how to simplify the terms. So that's why I'm not going to simplify this one and taking common. Again the video will be lengthy. So you just multiple these q into these terms and p with this term, so that you will get like this. Okay, you have to take the common of pq terms like that. Okay, so and the next is here pq in the sense what? 1 plus t square by 2 factorial is nothing but 2 into n plus t cube by 3 factorial in the sense 6 into np cube whole to the power of 3 by 2 pq into q minus p, again q plus p. Here a square minus b square is a plus b into a minus b. A plus b in the sense p plus q. P plus q is nothing but 1. So that's why we did not write here p plus q. Plus and so on power n. Okay, now applying log on both sides. Okay, now applying log on both sides. Log mz of t equals to log of 1 plus t square by 2n plus t cube by 6 into npq into whole power 3 by 2 pq into q minus p plus and so on whole power n. Okay, so here I am going to write log x power n, we can write n log x, no? So in this way I am going to write this n front. So n log 1 plus t square by 2n plus t cube by 6 into npq whole power 3 by 2 into pq into q minus p plus and so on whole power, nothing is there, and we have written here now. So again, now if you observe this one, it is in the form of log 1 plus x. Log 1 plus x formula is x minus x square by 2 plus x cube by 3 minus x power 4 by 4 plus and so on. Okay, so now in place of x, this full term is there. So this full term is called as x. So log 1 plus x. Now we are going to write in this way. So n log, that means n x, first x means 1 plus t square by 2n plus t cube by 6 into npq into npq whole power 3 by 2 pq into q minus p. This is x. Again minus x square, this means this full whole square by 2. 1 plus t square by 2n plus t cube by 6 into npq whole power 3 by 2 pq into q minus p plus and so on, here also plus and so on whole square by 2. Again plus and so on we'll write. Okay, so now what we have to do is we have to multiple this n. N is there, no? So here 1 we won't have, no? 1 plus x, no, sorry. So x in the sense only this term, no? Sorry. X square means only this part. So I have written this one, so that is wrong. So x means only this term. So x square by 2. Okay, so now what we have to do is this n we have to multiple this with this whole term. So n into t square by 2 in a is nothing but, first time I am going to explain you, n into t square by 2n is nothing but n get cancelled. So the final term is t square by 2. Okay, this is about t square terms. Again t cube terms, if you observe here t cube terms, only this term will be t cube terms. N into t cube by 6 into npq whole to the power of 3 by 2. And so on. If you observe here t square whole square, that means this is t power 4th term, not t square term. Here whole square we are having. So that means the final answer we are going to get is, m log mz of t, log mz of t equals to t square by 2 plus higher order, higher powers we will get, isn't it? Higher powers of n. Okay, so that's why we don't simplify everything, just we write only this one term. Okay, now what we have to do is applying limit n turns to infinity. Why? Because we have to prove this one only, no? N turns to infinity. So, limit n turns to infinity log mz of t equals to limit n turns to infinity t squared by 2 plus higher powers of n. Okay, so now what we have to do is this log we have to take from LHS to RHS. At that time what happens? So before that, here we have to substitute n turns to infinity, but here we are not having any n term. So that means simply we can write this one t square by 2. So that means limit n turns to infinity log mz of t equals to this term t square by 2. Now we have to transfer here log from this side to that side. So that means limit n turns to infinity mz of t equals to e to the power of t square by 2. Okay, so that means log, if we take from LHS to RHS, it comes to e power. Okay, so this is nothing but this is the moment generating function of standard normal variable. So that means here we have taken standard binomial variable and we got here standard normal variable. Okay, so you have to remember here t square by 2 we have to get. Okay, so other things we don't want, that's why we just simply kept here plus higher power of n. Okay, hope you all understand. So this question may be asked as normal distribution turns to binomial. Okay, or else binomial distribution turns to normal distribution. So they may ask both ways, but you have to write the same answer for both. Okay, hope you all understand. So if you are newly watching this video, please subscribe to my channel for latest videos and like, share. Thank you.